Hey everyone, I am Miss Hu, your physics teacher. In this video, we will learn how to calculate the time for light to travel a significant distance. This topic is part of the IGCSE Physics syllabus, so this video is designed to help students taking those examinations to prepare for their exams. So that's why this video is short and sweet. We're just going to learn how to calculate and solve problems for this particular concept. So first things first, you do need to know about the speed of light. And yes, IGCSE Physics students, you are expected to memorize this number. So speed of light is 3 times 10 to the power 8 meters per second. To solve questions where we need to find out the time it takes for light to travel a significant distance, it's actually quite simple. As long as you can recall the speed of light and you know the formula for speed, you can easily solve it. So what is the formula of speed? Let's quickly recall. So as we know, speed is distance over time. So given that we have the speed of light as 3 times 10 to the power 8 meters per second, if you are given the distance between the two celestial objects, then you can easily find the time. You just need to use this speed formula. So as you can see, all you need to do is just rearrange the variables in this equation and you can solve it. So the question will give you the distance and you have the speed of light and you can solve the time. If you are required to find the distance, then it's just a matter of taking speed times time. Let's go through a simple example. Let's say we need to calculate the time it takes for light to travel from Andromeda to the Milky Way, given that the distance between Andromeda and the Milky Way is 2.5 million light years. So to solve this, you just need to take the speed formula, which is speed equals distance over time. So I'm going to write that over here. But here's the thing, we can't just do an immediate substitution. Why? Because the speed of light as we know it is 3 times 10 to the power 8 meters per second. But if you look at the distance here, the distance is given as 2.5 million light years. Now, remember that light year is a unit of distance, not of time. 1 light year is the distance light travels in 1 Earth year. You cannot write 2.5 million where million is 10 to the power 6 because this unit is light year. I'm going to write LY for short. If you do this, you can't solve it because the unit for the distance is in light years, but the speed is in meters. The distance unit does not match, which does not enable us to be able to solve this straight away. So then how do we solve this? What we need to do is we need to convert the value of light years into meters first. So I'm going to put a big red cross first to indicate this is not the correct substitution. Well, they are correct, it's just that the units are not correct. So I'm going to erase this and we're going to start from this conversion of the light years into meters. So how do we convert a light year into meters? Now, some of you may have memorized, oh, 1 light year is 9.5 times 10 to the power of 15 meters. Okay, good for you. But if you can't recall this number, or if you remember this number wrongly, and you're like, oh my gosh, how do we convert this light years into meters? It is really quite simple. You actually just need to use the speed formula again. So the first thing we need to do is we need to find out the distance of 1 light year in meters. So I'm going to do this with a green color pen first so that we can see the difference. So this is the first part of the process. I'm going to write here number 1. To get the value of 1 light year in meters, we just need to use the speed formula. So I'm going to write here speed is equal to distance over time. So how do we get the distance? So the distance is basically speed times time. The speed in this case is the speed of light. So that would be 3 times 10 to the power of 8. The time in this case should be the time of 1 Earth year, because remember, 1 light year is the distance that light travels in 1 Earth year. But you can't just write times 1, right? Because the speed in this case is in meters per second. That means that the value of time written must be in the unit of seconds. So how do we write it in seconds? We need to convert this 1 Earth year into seconds. Now let's remember, 1 Earth year has 365 days. So we're going to multiply that with 365. 1 Earth day has 24 hours, and 1 hour has 60 minutes, and 1 minute has 60 seconds. So when you multiply all this, you will end up getting 9.46 times 10 to the power of 15 meters. Or as some of you may write, 9.5 times 10 to the power of 15. 2 or 3 significant figures, that's fine. I'm going to leave this as 9.46 because I find that the more decimals there are, the more accurate it is, but up to 3 significant figures is good enough. Next, how do we calculate the time it takes for the light to travel from Andromeda to the Milky Way? So we're going to go now to step number 2. I'm going to write this in yellow just to give you a clear distinction between the two parts of this process. For step number 2, we also need to use the speed formula, which is speed equals distance over time. But this time, we need to find the value for time. So when we rewrite this, we get time equals distance divided by speed. The distance here is 2.5 million light years. But remember, we can't just leave it as 2.5 million. We need to convert this light year into meters. So how do we do that? If this is the distance of 1 light year, let me just add that note here. So this is the distance of 1 light year. So if this is the distance of 1 light year, what we will need to do is take this value of 2.5 million times this value. So I'm going to write that here, 2.5 million, which is times 10 to the power of 6. We're going to multiply this with 9.46 times 10 to the power of 15. There's not enough space, so I put it into a second line. And we're going to divide this with the speed of light, which we know by now is 3 times 10 to the power of 8. So solving this, you will get 7.88 times 10 to the power of 13 seconds. And that's how we calculate the time it takes for light to travel from Andromeda to the Milky Way. So that's it for this video. I hope you found this video to be educational and helpful. So do like this video and subscribe for more free physics lessons. And if you'd like to help me keep making free educational video lessons and lab practicals, donations are welcome at ko-fi.com/physicsrocks. If you would like access to notes, quizzes, and syllabus updates, please visit my website at physicsrocks.com. Happy studying!